Hello everyone, my name is Jirat Pasuk-Smith. With my co-author Pathanamon and Janika, we are presenting our first journal paper, Story Point Changes in Agile Iterative Development. This paper was originally accepted at the Journal of Empirical Software Engineering. Agile software development is iterative and incremental. In Agile, the team continuously works in iterations of 2 to 4 weeks. In each sprint, the team creates the sprint plan, implement the software, and commit to deliver the software increments. So let's look in the detail of the planning process. The team used the product backlog to record the list of work items to develop the software. A work item is a task or requirements that contain the information to develop a piece of software. During sprint planning, the team performs detailed analysis to understand the work to be done. A work item is elaborated into more details at this stage. Then, the team estimates the size of work items. They usually use a relative unit like story points. After that, the team prioritizes the backlog and select work items on the top of the product backlog to work in the next sprint, while ensuring that the total effort fits the sprint capacity. Agile team estimates story points using planning poker method. Story point is a relative unit. 2 story point is twice as large as 1 story point. To estimate the story point, the team performs planning poker, which rely on the consensus of the team members. Story point can also be used to estimate the delivery time. For example, if the team can deliver a piece of software in 1 sprint, the whole software will take about 4 sprints to deliver. Achieving a reliable estimation helps the team create a reliable sprint plan. During sprint planning, the team estimates the story points based on the available information and allocate just enough workload for a sprint. However, expert estimations tend to be inaccurate, so the team may re-estimate the story points to maintain the accuracy. But if this happens after sprint planning, the total effort may exceed the sprint capacity. This can cause the sprint plan to be unreliable. The team may have to spend more effort in replanning or losing the customer's trust. The key problem is that the unstable story points estimation causing the sprint plan to become unreliable. In the first 3 RQs, we studied the prevalence of story points changes, the accuracy of the changes story points, and association between story point changes and information changes. Then we proposed an approach to predict whether the story point will be changed after sprint planning. We conduct this study in 7 open source projects containing 19,000 work items. So in this study, we only consider the story point changes that occur after the work items were assigned to a sprint. In RQ1, to what degree do story points change? We found that only 3 to 17% of work items have story point changes. 88% of the work items with changes story point have only 1 story point change event, and story points are typically changed by at least 58% of their size during sprint assignment time. This suggests that story points are not often changed, but the change can have a negative impact on the sprint plan. Now we know that story points have a large changing size. In RQ2, we investigate the accuracy of the changes story point. We study the accuracy of the changes story points in terms of reflecting the development time. First, we measure the time period that a work item is in progress. Then, we build mixed effect models to capture the linear relationship between story point and the development time. By measuring the accuracy of the model. We built 3 models for 3 versions of story points, which are unchanged story points, changed story point version during sprint assignment time, and the last version of the changed story points. We found that the unchanged story points are the most accurate. Even after re-estimation, unchanged story points can better reflect the development time than the changed story points. In RQ2, we know that the unchanged story points can better reflect the development time than the changed story points. Next, since story points are estimated based on the available information, but it is unclear to what extent a story point change are associated with information changes. We focus on the relationship between story point change and information change in a work item. We first investigate their co-occurrences by measuring the feature-odds ratio between the work items with story point changes and the work item with information changes. Then, we investigate the types of information changes by perform open coding to derive the list of codes and use the code to classify the information changes in the projects. We found that after sprint planning, story point changes often occur along with information changes. I identified 2 categories of information changes, which are for changing scope and qualification. I found that the changing scope often found in the work items with story point changes. These findings suggest that story point changes often occur along with information changes for changing scope. In RQ3, we know that the story point changes often occur along with information changes, especially for scope modification. In RQ4, we propose an approach to predict future story point changes. During sprint planning, the team selects the work items from the product backlog to sprint backlog. Since story point changes may occur after that, the sprint plan may become inaccurate. But checking all work items could be a tedious task. To help the team save effort in managing the uncertainty, we propose an approach to predict whether a work item will have story point change after being assigned to a sprint. The team can select the work items with the low probability to the sprint. For the work items with high probability, the team may perform detailed analysis and re-estimate the story points or reserve buffer time in the sprint for the uncertainty. We built machine learning models based on 41 metrics extracted from the work items in the dataset. We built and evaluate the models using 4 machine learning techniques. Note that we only focus on predicting the story point change that occur after the work item is assigned to a sprint. We measure the prediction performance based on 100 bootstrap sample datasets and compare them among the 4 variations and against 4 baselines. We found that logistic regression model achieved AUC of 0.72, outperformed the other variations and the baselines, suggesting that our approach can predict story point changes that occur after sprint planning. In this paper, we found that story points are not often changed, but their large changing size can impact the sprint plan. The unchanged story points can better reflect the development time than the changed story point. Story point changes often found along with information changes for scope modification. And lastly, our approach can predict the story point change that occur after sprint planning. Agile team can use our approach to manage the uncertainty while saving effort. And that's all for my presentation today. Thank you so much.